Welcome to this video, guys. Today we are going to be looking at exercise 11A for the Edexcel PM2 book. So stay tuned. When we differentiate, we take the power down. So for example, if we have y is equal to x to the power of 5, for example. When we differentiate this, what do? We drop the power down here. So to give us 5, x to the power of 4. That's differentiation, yeah? Now, a reminder for integration, if we were to integrate something, so for example, let's integrate this itself, yeah? So we want to integrate, and this is a symbol for integration. We write 5x to the power of 4. With respect to x, this is what we do. We write this when we're integrating, so with this symbol and that. So what do? Quick reminder, how do we integrate? What's the process? We add 1 to the power, and then we divide by that new power. So if you add 1 to this power, what do you get? X to the power of 5. So x to the power of 5. And you've got the 5 there already. And now you divide by this new power like that. Yeah? And these cancel, giving you just x to the power of 5. But there is one extra step that you need to do, which is you'll have a constant. So you write plus c. Okay? And that shows that this has been integrated to this. So if you have, for example, x to the power of n and you want to integrate this, as a general rule, you add 1 to the power, giving you n plus 1. And then you do what? Divide by the new power, which is n plus 1. Now, another way we may write this, and plus c. Another way we may write this is 1 over n plus 1 and x to the power of n plus 1 plus c. Are you happy with that? Let's have a look at e to the x dx. So what do? Now, you may not see this straight away, okay, when it comes to other functions like the e function or the log function or the sine function. And what we do is something known as a reverse chain rule. We're going to look at reverse chain rule in exercise 11D properly. And what the reverse chain rule does is it considers what this would have differentiated from. So for example, if you were to consider, and you'll see and you'll get the hang of this once you do a few more examples, if you were to consider y is equal to e to the x, and I asked you to differentiate this, what would be the differentiation of that? E to the power of x. But what happens is you differentiate this, x, the power, and then you bring it down, and if you differentiate x, what do you get? You get 1. Okay, so you write the 1, but we don't write it, and then you write the power. So 1 e to the x, right? And then you look at the difference. So remember what we said, that integration was the opposite of differentiation. So to integrate e to the x, you get e to the x. So to integrate that, so let's write I for integration, you get e to the x plus that c. Make sense? Let's have a look at another one. So let's have a look at 1 over x. So we are going to integrate 1 over x with respect to x. So once again, what we're going to do, we're going to consider where 1 over x comes from. Okay? So where does 1 over x, if you had to have something, what differentiates to give you 1 over x? ln x, yeah? So ln x. So when you do dy over dx of ln x, what do you get? 1 over x. So now, have a look at what you have and what you have there. It's exactly the same, isn't it? So therefore, the opposite of this, to integrate this, you get ln x. So the integration of this would be ln x plus c. So let's have a look at a few more examples. We've got cos x, sin x, sec squared x, and then we've got these 3 as well, okay? So each time, what we're going to do is we're going to consider what it differentiates from, okay? So let's go back to cos. So what would we consider here? What differentiates to give us cos? Sine. So we would consider sine of x. Now, when you do the dy over dx of sine x, you get cos x. So therefore, the integration of that would be sine x plus c. Very good. Now, have a look at sine x now. So you know what's sine x linked with when it comes to differentiation? Cos, right? However, when you do the consideration of this one, when you do y equals, so for example, cos x, and you differentiate dy over dx, when you differentiate cos x, what does it actually give you? A minus sine x, right? But we want to have a positive sine x, don't we? Yeah, so what we can do here is we can consider, instead of considering just cos x, we'll consider minus cos x. So now watch what happens. If we were to differentiate this, what do we get? We got the minus here already, and you've just said that the differentiation of cos is minus sine x, and then these two minuses, what do? They cancel out, giving you a positive sine x, which is exactly what you want. So therefore, the integration of sine x is minus cos x plus c. So sec squared x, what does sec squared x differentiate from? What are you going to consider? Tan, did you say? Yeah. So consider y is equal to tan x. So when you do the dy over dx of tan x, what do you get? Sec squared x. So therefore, what's the integration of sec squared x? It's going to be tan x plus c. In the next exercise, 11b, we're going to start looking at the reverse chain rule and how we might have to make some adjustments to our consideration. You've seen one in the previous example where we had to add a minus, okay? But we'll make more adjustments like that with the coefficients, okay? Right, so you want to do these ones? So let's have a look at this cosec cot x. So we'll do the consideration here. So what are we going to consider? Just so remember what differentiates to give us cosec and cot. So cosec itself, yeah? So if we consider cosec itself, cosec x, dy over dx is what? It's actually minus cosec cot x, if you remember from differentiation, yeah? So therefore, we don't want a minus, we want a positive. So what can we consider instead? A minus cosec. So it will be, now it will be minus, and then the differentiation of that is minus cosec x cot x, and then the two minuses will cancel, giving you a positive cosec x cot x. So therefore, the integration of this would be minus cosec x plus c. This next one, what do we consider for the next one here? We are going to consider what? So what, don't worry about the signs, just think about cosec squared. What does it differentiate from? Cot, very good, right? However, if you look at cot of x, it differentiates to a negative cosec squared, doesn't it? Yeah, so dy over dx would be cosec, but we want a negative, so therefore a minus already, and then the cot becomes a negative cosec squared x. So a positive will come out of this, so therefore the integration of cosec squared x will be minus cot x plus c. Now if you want to do a little exercise, what you can do is you can make a little card, and you could have on one side the function and what it differentiates to, and on the back of the card what you'll have is the function and what it integrates to. And the more you use this, and you can quickly flip over and use this while you're doing your exercises, the more you're going to get used to what the differentiations and integrations of each one are. Let's have a look at sectan dx, yeah? So what will I consider for this? Where does sectan come from? It comes from sec, okay? It comes from sec x. So when you do the dy dx of sec x, you get what? Sec tan. Right? And there's no sign change because this is exactly as we want it, right? So therefore, the integration of sec tan is sec x plus c. All right, so let's have a look at the first example on this one. So we've got 2 cos x plus 3 over x minus root x dx. Very straightforward one. We might need to standardize certain things. So here we will make this into a x to the power of a half. All right, so we can just write minus x to the power of a half here. So when we come to read this, we'll just read that instead. All right, so when we integrate cos, right, so if you consider y equals, so when you differentiate sine, you just get cos. So we want sine x, and the 2 is already there. Okay, so 2 sine x. What about this one? That's going to give us plus 3 ln x. This one now, obviously we're going to be looking up there. So we add 1 to the power. So we get x to the power of 3 over 2. And then we divide by 3 over 2. But we will flip that. So instead of dividing by 3 over 2, we can multiply by 2 over 3. And then we write our plus c. Now this one, again, you're probably looking at this thinking of quotient rule. But quotient rule is used for differentiation. So don't get confused with that. What we can do again is just break up this fraction. We can have cos x over, you see we've got sine squared here. So we can have cos x over sine x times by 1 over sine x. And this gives you exactly that, doesn't it? Yeah? So what's cos x and sine over sine x here? What can we simplify that to become? We can simplify that to become cot x. And 1 over sine is cosec x. So what we really are doing now is we are going to really integrate this, but for that. And we've seen the result of that. Where does this come from? Where does this come from? It's usually cosec cot. Cosec. So minus cosec x plus c. Right, now let's have a look at this interesting one. This is definite integration and it's also an equation that's been made to equal to ln 12. So step number 1, we can simplify this fraction. Okay, so how can I simplify this fraction? I can have 2x over x plus 1 over x dx equal to ln 12. And we can put our limits in here like that. The x's cancel, so what are you left with? 2. So let's get rid of this and we can just write 2 there. And let's integrate this half. Okay, so what do we get when we integrate 2? 2x plus, when we integrate this, ln x. And that's integrated now. We don't need to write plus c because we're going to be solving it. Plus, it's a definite integration. So we can put into a bracket like this, write 3a here, a here, and we can write our ln 12 on the other side. Next, we're going to substitute those values in and take them away. Okay, so the first bracket we will have 2 times 3a plus ln 3a. That's our first bracket. Take away the second bracket where we'll substitute the value of a in now. So we'll have 2 times a plus ln a, our second bracket. And this is all equal to the other side, which is ln 12. So now we just need to tidy up. So what does this give us? 6a. So I'm just going to get rid of this and write 6a. So now I have, I can take the brackets out completely, right? But I'll just, for space sake, I'm just going to do 6a minus 2a, which is 4a. And I've got ln 3a minus ln a. So what's that going to be? It's going to be plus ln 3a minus ln a. And then on the other side, I've got ln 12. Now, the laws of logarithm. What can I do right there? I've got ln 3a minus ln a. I can divide 3a over a. So if I get rid of this, I can have ln 3a over a. And what's ln 3a over a? Simplified to, we can cancel out the a's. Once we cancel out the a, what do we really have? ln 3. So we have ln 3. What's my next step? I want to find what my a value is. Okay? That's what the question wants me to do, to find what a is. So I can take this to the other side. And what do I get? I get 4a here. And then I will have ln 12 minus ln 3. Once again, I apply the division rule here for the logarithms. So I get 12 over 3, which is 12 over 3, like that. Yeah? And 12 divided by 3 is 4. So ln 4. Finally, I want a on its own. So I'll have a is equal to, what do I do to get rid of this? Divide by 4. So I could write ln 4 over 4, or I could write a quarter ln 4. And that is an expression for a. Hope you enjoyed that one, and I'll see you in the next lesson.